Hey guys, welcome back to the channel. My name is Jan and this is another episode on the Minuteman project. First of all, thank you so much for all the positive feedback I got on the last video building the hot end. It's a pleasure to have you guys in the comment section. I freaking love it. And we're gonna address something all you guys pointed out in today's episode, and this is how about mixing and putting different colors in it and seeing what our options are. I never really intended to do stuff like that, but since you guys are so interested, let's just give it a shot. Also, second thing in the comments is, where is the printing? So we're still at 1, 2, 3, 4, 5 things, or let's call that blob a 6 print. I'm in the preparing for setting up our next benchy, so I thought, why aren't we doing this in 4 colors and see what the results are. I finished up some parts on the hot end, which I'll explain later on. But first of all, let's play the intro tape and let's get started.
Da 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 da.
So the filament is already loaded up. But before we extrude some material, we have to talk about what's going on here, because for continuity's sake, let me get you in closer. So there are 2 things you haven't seen before. And first of all is this like heating sock element, which is made out of an SLA print of an high temp material. So this should be okay to 290 degrees. We're going to see if that works out or not, or if we have to do something else. I do have another option available, but we'll prototype with this approach. And also there is the cooling situation. In the last episode, I gave you a little bit of a teaser on that, and also I involved Mike from Needed Make It channel to do some proper testing. We're just gonna see some ballpark results here. And as you can see, this is bound in the existing structure to address the rigidity of the system. So basically, I can push pretty hard. Is as rigid as I wanted to have it. I do have the cooling system hooked up to the shop air, and this is actually needles from like these little pumps for inflating balls and such. And I'm just going to increase the pressure until like it starts to flow. And you can hear that very faint. The regulator isn't picking up any pressure on here, but you can already feel the cooling power. And it's very, very condensed to a single point. When I designed this in CAD, all these needles point like straight down from the nozzle, like 2 millimeters down there, to really effectively cool the stream of just extruded material. The whole sock situation is there to prevent from getting the nozzle blown cold. So now I'm gonna take this needle with this piece of yarn attached to it. And this is at very, very low pressure. You can already see how laminar the flow is. There's not much turbulence going on. And of course you could have gone a different route and have like something like a vortex or surrounded everything. I think this is not effective enough because, as Mike already pointed out, we need to get somehow rid of the warm air that has been cooling our extruded material. And he's been always talking about a sheet of air that is cooling the whole system. And that's essentially what I tried to do at a very low angle, and just have this 7 needles which are like 120 degree of rotation around the hot end. And I'm gonna increase pressure even more to the max. You won't hear shit, but yeah, see what the yarn does. Alright, so far for the cooling part, right at the end we were about 2 to 2.5 bars of pressure. I think this is more than plenty, and it's been limited by like the back pressure of those needles. I think the pressure at that point is so high that the filament would just blow off, and that would be pretty bad, especially for the parts where you need to do bridging or stuff like that. So what I didn't mention in the last episode, even though this has 250 watts of heating power, it takes roughly 4 minutes to get this to work in temperature. I set the set point to 215 degrees, and then we're going to start feeding some material in, and let's see what our results are here. I haven't done this myself. My predictions are we do have, or we try to have, turbulent flow in the upper part by making the surface rough. But in the lower part, we have everything polished. So I guess we're going to end up with some pretty laminar flow from the point on all these get together. And I think we don't have that much of a mixing effect because plastics tend to have very laminar flow. But my theory is that the both most outer channels intersect the 4mm bore at a slight angle. And that way I think they're going to overshoot a bit in the middle. So I think the blue and the violet part are going to be somewhat more mixed than red and yellow. Alright, I'm taking you on the maiden voyage. It has reached 215 degrees, and because we're gonna have very melted material, it's starting to flow out of here. So let me do 100 millimeters of filament at an extrusion rate of 50 cubic millimeters a second. Just gonna hit extrude. Alright, all the 4 strands are pulling. Alright, this was 50. Let's add another one at 100 cubic millimeters. For good measure. Alright, so let me see what we got here. Let me get you closer. This is what we're dealing with. This is the 50 millimeter cubed extrusion rate. As you can see, 2 colors are very dominant, which are the most outer ones. Let's call it extruder 1 and 4. They seem to be wrapping around the inner colors. They are pretty much non-existent. You can see a very faint yellow, orange-ish line out here. Red is pretty much not existent, I would say. Or maybe there very, very faintly. And this is the same at 100 cubes. I cut a grain from the first one. Let's have a look under the microscope. Okay, I have no idea how good you can see that, but it's pretty obvious what's happening here. So the red and yellow are actually embedded in the middle, and blue and violet are like covering it on the outside. There's also something we haven't talked about yet. Even if all the filaments are from the same company, this is all like PLA Plus by Kingroon, different colors tend to have different properties, and I think that's exactly what we're seeing here. Blue seems to have the lowest viscosity of them all, and it's like flowing around the inner core the most, at least more than the violet part. Yeah, that's pretty much what we can get out of here. I'm really curious to see how that looks in a print. I mean, which 3D printing model would be best to check that out? You got any ideas? Okay, let's see what kind of difference it makes if we go up with the flow. Let's make it 150. This is at 215 degrees, by the way. And let's make it a 200. All right. So I don't know what to read from that. This is being extruded thicker due to the die swelling. This would have been the better thing to have a look at the microscope, but essentially you can see the same effects. The violet and blue parts are the most dominant here. All right. Printing, printing, printing. I hear you guys shouting from here. So I guess you saw some footage just now of me doing a dry run with all axes moving but without actually feeding filament. I think this is the next step. I've sliced up a benchy which will be somewhere in the 4-minute range. There's no need to go balls to the wall. We're gonna test huge amount of things, and as I've said before, this is like the 6th real print I'm gonna attempt on here. Let's see how that goes, and the main goal for it is to finish and get some valuable data about like cooling, hot ends, whatnot. In terms of we don't have air in our air bearing situation here because I only have one of those pressure regulators and I need that to adjust the cooling flow. So we're just gonna run that dry, but it's certainly gonna stop the moving platform from tipping around. So it's just the glass plate with a very thin clearance for the moving part. Also, I'm running these motors at just 1 amp, and I think I'm gonna set the hot end to 215 degrees because we're not using that much flow. And I'm gonna slowly ramp in the cooling after like 3rd layer or something. This is just some masking tape with some glue stick applied, so we're gonna see what the sticking situation will be. And then I sliced this benchy with mediocre speeds of somewhere from 800 to 1500 millimeters a second, and maximum acceleration will be at 150k. It's also 0.2 millimeter layer height, so we're gonna see if we can like print a quality benchy at that speed. Let me get the camera set up, hit go, and see what happens there. I'm hyped. All right, another try. I've fiddled around a bit with the retraction settings. Actually, before there weren't any, so I gave it a little bit of that. I'm gonna make it a lot slower at the start, and then we'll see how far we can pump it up. So what I found is, even that I made a pretty big like priming object, it still isn't enough to get like the juices going inside of that hot end because I have so much channel length. What I do is keep that shut extrude some material in there, and then just hit go. This is at 25% speed. First layer is pretty slow initially. I'm slowly ramping in the cooling. So this is at 25%. I'm gonna up it to 50. So this has been an 821 print. I guess the priming was somewhere in the 20 to 30 seconds neighborhood. So let's say it was an 8-minute benchy. Run at 50% and the slicing estimate was at 5 minutes 26, so that somehow matches. So as you can see, this isn't a permanent solution, but for now it does work. This will have caused some problems at the upper sections, I guess, but it does actually stick quite good. So there are a few things I do like not, but the majority of it is just awesome. Again, this is the 6th print this printer has ever done. There's still no input shaping, no pressure advance, no nothing, no parameters. I mean, you see the stringing in here, so basically this print I did some arbitrary retraction settings of 1 millimeter of filament, which is like, you saw the times. The extruder's parameter are way too slow. It was 1.5 minutes of pure retraction during that print. So I have to go home now, but we'll talk about that tomorrow. I think it's pretty interesting to see that one side of it has this like bluish color, and then straight, like if you see the diagonal through the part, it gets like violet shifted. It's really strange. I haven't seen that anywhere else. Hey again. So it's actually the next day. It's a Saturday here. It's pretty cold, but we're gonna do some testing anyways. I got a few hours to spare. So let's have a look again at our model. I didn't like change anything on this. So that's how it's looking. It's like tipping because right in the middle there is this small thing which is embedding itself right here in the middle where the screw is on the build plate. In the first episode, we talked about the 3 main things we have to get going to reach our goals and print a sub 1 minute benchy. All right, starting with the first one, the motion system. So even though I just had it down at like 25% up to somewhere in here, and then to 50% of the maximum speed, still the accelerations are not being affected by that. So what you're seeing here is tops 150k of acceleration. Since we're not using any input shaping whatsoever, I don't think it is too bad. I mean, there are certainly a lot of things we have to investigate. My main thing right now is, and that's also the reason why I'm just running these at 1 amps, if these motors get slightly too warm and the plastic is kind of softening, it will actually cause these pulleys to rotate on the motor shaft, and that's causing problems, so I'm keeping those under like 60 degrees or something like that. In later versions, I have these already ordered in a future-proof material, SLS and SLM printed, and then we're gonna add input shaping to the mix and see where we end up. The second issue we identified was extrusion, and it is estimated at 10.75 grams, and when I put it on the scale, you can actually see there is no sign of under extrusion, and that would surprise us big time if that would be a problem for this hot end. So we're far, far away from reaching our limits here, which is a very good thing to have a lot of headroom. Of course, most of the problems you see here are due to heavy stringing and retraction settings. I did some arbitrary amount because initially it was turned off and the speed was very, very low. So just having retractions on this sliced benchy added the time from 4 minutes to 5 minutes 30. So 1.5 minutes of pure retractions. And that is something that doesn't go along with this hot end style. In those seconds where it does the retraction, there's so much material flowing after, and than just oozing out of the nozzle. For the next test, I'm gonna run the same G-code with same printing speed, etc., and just disable the retractions completely. I mean, for something like a sub-minute run, we ain't doing retractions at all, for sure. But for somewhat quality prints, I think it would be a thing to have a look at. And what we have to do is run some tests on the maximum speed these LGX can run at and do retractions at before they do lose steps, because they have like an internal gearing as well. So we'll see how much of retraction we can run. But if you think about it, we like only need 1/4 of that retraction value to actually move those filament back quite a bit. The third issue we identified was cooling. And I think that's what I'm most hyped about here. So even though I was again just running some arbitrary numbers, I think I was at like 1 bar or something, we do not have any signs of cooling issues. So let's just have a look at these upper parts here, where there is that bridging on the windows, etc. There is so much headroom in terms of cooling. And also, the chimney wasn't too slow. I think it was a 0.2 second layer time for those. And it is actually pretty decent. The hole is pretty round. There is, of course, some artifacts from the motion system, but I think cooling-wise, this turned out pretty good. Also, there are a few things to investigate on the cooling. I could see on the heat controller that it was causing the heaters to turn off, on and off, depending on where in the model we were. So if there was like an open space just below the nozzle tip, like in this upper section where it's just gonna do those pillars, the temperature in the hot end was dropping off significantly. But then again, for first layers where it was very close to a flat bottom, it actually turned off the heaters and there was no severe cooling effect on all the copper and brass hardware. So, a lot of stuff to investigate here on these prints. Let us do the following. We're gonna rerun this without retractions and see where we end up there, if we can have a really easy fix for that stringing issue, and then work from there on. Let's do that. So short maneuver critique over here. This is 6th print, this is the 7th print. And as you can see, not doing the retractions at all didn't help. It went faster. It is like a, let's call it 5 minutes 30 print. Like the obvious artifacts from the motion system are the same, I would say. I think I got earlier onto the 50% speed override, which is basically here, and yesterday it was somewhere in here. Cooling is an issue here, but I was this time pretty low on the pressure, and there is, I mean, just rotating the part would be a smart idea. It's sitting like this right now. I think it would actually be in this orientation would make the most sense, but we have to test that. Maybe it is even in this, because then the whole air is blowing off this front lip all the time. 1,000 things to test here. This got worse, so let me run a quick test on how fast we can do retractions on these guys. And let's run them full blast in terms of speed, and then give like each of these extruders like a millimeter or something of retraction and see if this gets any better. Alright, we're gonna rerun this 4 millimeters of retract, which will be 1 millimeter per extruder, and we're going to run that at 500 millimeters a second. That's really fast. I have no idea if that makes any sense in terms of filament retraction, but the LGX can handle that, so let's have a look. That was interesting. So I guess we're going in the right direction. This doesn't seem to be enough retraction or whatever. Maybe because I'm pulling so fast to actually cause some vacuum inside those melt channels. Also, the melt channels are really long, so I have no idea if retractions are really working in some kind of a concept like this. As you can see, stringing got less from the previous attempts. And then what happened here, I'm not quite sure. There are some signs of a short time where it wasn't really extruding, but this time I had the cooling pumped up to 2 bars, and if you compare them side by side, this is the same speed. The 2-bar version actually made a big difference, so this is considerably better in terms of cooling. But then on top, what I was seeing is that it was actually blowing off these pillars. There was not enough time to actually bond to the layer below, and at some point it cracked here and it just blew everything off. And I think I got some footage of just blowing a laminar flow of extrusion right towards me. What I'm really happy about is that I can pretty much run back-to-back tests. The motion system was working flawlessly up to now since, well, now I mentioned it and I jinxed it maybe. I want to go ahead and turn this around in this direction, because what I'm seeing is that especially when it's doing this front lip here, which needs most of the cooling in the lower part, it actually doesn't get too much of a cooling effect, because most of the time the nozzles are in this region. So let's turn that around, and I'm just going to go with 1 bar of cooling on those nozzles. So let's see if less cooling is actually more cooling. Forget what I just said. This is the 8th and 9th print, and this time what's the difference is I cut the speed of the retraction in half, so 250 millimeter per second. I'm going to increase retraction settings by twice the amount, so put it to 8 millimeters. That equals 2 millimeters per channel, and I'm going to go like 5 degrees less on the nozzle, and then I'm going to do what I actually wanted to do and turn this around. I just simply forgot. So again, babysitting the first layer. I don't know where these squeaking sounds come from. My suspicion is these screws work their way up and are against the glass surface. Okay, gonna increase. Number 9, number 10. So the stringing, I mean, it looks different on camera, but in person this has way thinner strings and way less. This is, let's say, a quarter of what's happening here, having longer retractions and 5 degrees lower. I think what I will do next is maybe get the retractions even higher, go another 5 degree lower, especially on the upper block, maybe even 10 degrees on the upper block. And then I'm gonna increase the accelerations on the travel moves by almost double or something to make the time in air as low as possible. Also in terms of cooling, I think this wasn't actually helping. I think I'm gonna try reversing it 180 degree from the last attempt and print it like this. Again, this upper part has been blown away by the cooling system. This time it was at 1 bar, just like the last one, but yeah, eventually it blew off. Let me run another G-code. Okay, so in the 11th print, I got down and down with the temperatures of the upper block. At the end I was at 190 degree. And apparently you can see it in the under extrusion on top. It wasn't able to keep up with splitting the filament. That's at least my theory. And I noticed some weird noises mid-print, and as you can see here, apparently some filament worked its way in the large gear extruder. So let me do a quick maintenance on here, get this out of here, and note to myself, don't go down too much with these values. Alright, so I just loosened up these two top screws and the front cap got off easily. So as you can see, it was just feeding it in there like a maniac and actually split it down those two paths. I unhooked all of these in their like 0 position, so they're free. And now I do a retraction move of, let's say, 20 millimeters, and let's go pretty slow. Let's see what happens if we can get it unstuck. I'm an idiot. That was the wrong direction. What? No. Let me get that out of here. Okay, I need both hands to do this, but I think we're up and running again pretty soon. Maintenance is pretty easy on these guys. So I got it out, but it was a bit of a pain. It has nothing to do with these extruders, but there is something I did talk about but never included in the video I was making about that hot end, because in those tests it just worked out, but I think I just found like the limits. So the thing is, with these 4 melting channels, we can actually run into problems if not all 4 extruders are pushing at the same time. So in the film about the original 4-filament hot end, I found the issue that if I just push into one channel, instead of going out on the nozzle, it will actually push up in one of those other channels. And I think this is what just happened here. So this one had some kind of an initial problem and couldn't get the filament going. Maybe the red one is the one with the slowest heat transfer or something like that. So there is an initial problem, and it can't keep up with the pushing. What ends up happening is that melted material gets up there in the first few millimeters of the heat break and cold end. Once it solidifies there, you can push like a maniac, and I just did that with the pliers, etc. You can't get it out of there unstuck. So it is a real issue in real-world application with this kind of setup. All 4 extruders have to push at the same time. If there's a problem with one of them, it's gonna screw up after that. I had a backup plan when I was building this, and this worked kind of. I took like a gas torch and heated the very first few millimeters of the cold end just by a few degrees to get it to a transition temperature, and then I could pull it out with the pliers, and if you have a look, it was basically stuck right here. You can see where I had to shear it off down there. So if you guys want to build a setup like this, there were a few mechanical options we could get around that by adding like Tesla valves or whatever into the channel, so it is very hard for the other extruder to push material up into another channel. But I didn't want to make this any more complex as it is right now. So I know from the first minute on that I never will push filament just one inside there without the others running. It all has to be done by the extruders, and we have to make sure all of them are running at the same time. This is fixed for now. I'm gonna put it all together, then I have to leave again for today. But I think we made a lot of progress in just a matter of a few, I was here for like 2 hours. You get a very fast response in terms of iterating, and that is pretty fun right now because this has worked flawless for the whole testing today, and I'm gonna revisit that tomorrow or starting next week or something. But for you guys, it will just be in the blink of an eye, which is now. So it's a few days later. I think I fixed this, and also I swapped the blue and the yellow filament roll. So expect a little bit of a different mixing color. But also I've switched my tactics, and now we're going with the upper block with more heat to prevent anything from building up too much back pressure to the extruder. We don't want to have that clogging again. But this time we're actually trying to use the nozzle itself, just the tip, to actually cool the filament again. Let's try 190 degrees and see if that makes any difference. And yeah, my plans for today are run another test to see how far we can get oozing down before we go into pressure advance and all that stuff. Then I want to hit the benchy at a solid 100% of my sliced coach, which will result somewhere in the neighborhood of a 4-minute benchy. And then I would like to do a balls to the wall run in terms of how much filament can I push out of the hot end, and just build like an XYZ calibration cube or something with like 300 cubes of filament flow. We have to talk about die swell, etc., but essentially this is what the nozzle is: a 0.5 millimeter in diameter, but the filament that exits it is at a bigger diameter, so it basically swells up again. This effect is called die swell. We have to talk about that in a minute, and also see what the results are in real-world applications. See if it makes a difference if this material is being deposited right away or is it just being extruded to free air, I guess. So I want to do these 3 tests now and then see where we end up. So this is how test 12 turned out. It's a very interesting color combination, to say the least. But yeah, I started with 190. I noticed it right away that it was way too cold, because when I do a set point of 190, that's at the temperature sensor. I guess the nozzle tip will be a lot lower than that, maybe 140, 150 or something. It does manage to push this through, but as you can see, it doesn't like that too much. And then in this region, I was at 205 or something. Especially for these very short moves here, I think this is not sufficient. But in terms of oozing, stringing, this was the best so far. I ripped this apart when I was getting it off the build plate. So at least in the lower section, this isn't too bad, and I think with some fine-tuning we'll end up here. But yeah, let me crank up the temperatures again. Also, one thing I forgot to mention, this now has 250k of accelerations on the travel move, so that is reducing the time where it is possibly oozing again. So it is a combination of all the things I put in here. So let me run the 100% sliced benchy. I'm gonna baby it for the first layer at 25 or something, just to make sure it sticks. Then in layer 4, 5, 6 or so, I'm gonna give it the beans and we'll see how it turns out. So if all these little segments are starting with me saying, huh, interesting, well, yeah, that's because we're seeing those results together, like for the first time. I also bet that you have never seen a benchy like this. So that was like a 5-minute print. And as you can see, it's kind of a like bipolar result. If you had a look at this side, it looks completely different than on this side. That should tell us a lot of things for like the stuff you're suggesting with the CMYK filament. So I could either tune this for this violet purple one, or I could tune this, well, yeah, for whatever that color is. So I guess for reliable results and good retraction settings, I need to settle on one filament only. I mean, these are all from the same manufacturer and also the same filament line. But as you can see, this is 2 stories. Have a look at the walls to the right side, which are yellow dominant. And then this inner side here, which is also to the right. Everything that is in this violet shape is actually not looking that bad. I mean, of course, there's severe ringing up here. This is also not a slow print. And if you would like get away all this messiness inside, wouldn't actually look too bad. I also noticed something about the extruder setup itself. So The retraction settings I have on here, seems like it's stuttering up here. I could see that during the chimney part. I don't know if that's has got anything to do with maximum speed of the controller or whatsoever, because I'm running these at 24 volts. These aren't attached to 60 volt supply. So yeah, let me have that in here. I want to see another test where it's less about retraction than just pumping out huge amounts of material. Let's do an XYZ cube scale to 200%, so it should be 40 by 40 by 40. Crank up the flow to, let's say, at least 200 cubes and make it solid. See if everything keeps up and how that is looking. We have to find out if this hot end is only capable of going full blast with like large nozzles and extracting a lot of materials, or if we can actually do those tiny little controlled moves. Let's see. Alright, I scaled it to 30 by 30 by 30. The outer walls are being extruded at a flow of around 60 to 70 cubes, but the completely inside is at 250. So let's see how that goes. Okay, that's how it turns out. Clipper just went into error mode because it couldn't keep up with the heating. Presumably I put up the cooling too high and the heater wasn't responding fast enough, I guess. So let's try to pull that down there. So if you just have a look at this piece here, this is looking actually pretty promising. I mean, not down here, but up here. But if you ask me, I have to get rid of this variety of filaments. This can't lead me to any good results. So and before you ask again in the comments, I already went ahead and bought some CMYK filament. But before we get into that, we have to get one of those calibrated properly. I think next time we'll see one filament in there, so we can get more reliable results. But this was a fun test anyway. You just saw me putting the one of the violet spool that was like 800 something gram left, and I put that on these 4 ones. Already got it in here. Also I've made another few minor changes. I masterfully taped this lightning to this mag base, and also I did this kind of a pneumatic mess. So with this guy I can control the air bearing down there. I can just set it to really low pressures. Let me show you what I mean. If I get it any higher, this plate starts to be excited at their resonant frequency. As you see, this is just a temporary solution. The later glass plate will be like 8 or 10 millimeters in thickness. and be water jetted or something like that. So also I've put in this little aluminum bracket from TIG wire that prevents this piece from opening up here. When it gets warm, since it has not got any bracing around the front, it widens up and loses its shape there and yeah, isn't really holding up. So with these changes, let's rerun the high-speed extrusion test and see if we can print an XYZ cube. I'm gonna start by 25% speed override. Let's see what happens. Okay, I got cooling up to, let's say, half a bar, and now I'm gonna ramp up the speed. This is 50. Well, and again, clipper shut down because it thought there's some problem with the heating situation. It was going full blast, but temperature was dropping. I have to check for those values to give it a bit more headroom. So there are a few things that don't really add up, and I've been investigating for the better part of the last hour. So if you have a look at this side, this looks pretty good given the speed we're extruding the material, and this has been a solid piece. But then, if I rotate it, this is looking different, to say the least. This is looking worse. And if you just have a look at this part here, ignore all the upper stuff, this is where it crashed at the end, it is looking okay-ish. The same with the second part. Have a look at this side, this looks actually pretty good. Again, this was the x-axis, opposite side, and this is the one towards us. So you could argue, well, that's because of cooling, but I pretty much don't think that this is the case, because this is the one to the right, and you would expect this and this, because it's symmetrical, to be at least identical, but that isn't the case. And then I did some further investigating here, and this is at 215 degrees again. I'm going to extrude some materials at 120 cubes. This has been cooking in there, but see what I mean? It has the tendency to walk to the left, looking at it from the front view. So what that could be causing is to have different temperatures in all these channels. And I have no idea how I should film that, I got the thermal camera out here, And here I can adjust the range. And counting from the right, see the cursor, this is, let's say, extruder 4, and this is 3. And if I increase or decrease, see these ones fade out first. At least for line 3 there is a significant drop in temperature. So it's either the heater at this lane is broken and not heating at all, or it has a different resistance than all the others and is given less performance. But I'm gonna have to investigate what's up with the heaters and see if we can draw a conclusion from here, because we added so many things in our list of possible problems here with all that junk we built in here. Okay, I've taken this apart, marked where each individual heater was located in the heating block. Then I attached this heating probe, gave it a temperature set point, and then took my most accurate temperature probe to measure all of those against each other. Yeah, and this is the average. If I had just one of them that was slightly above on the others, I would have just put that in the middle, but since we have two of those that don't actually match, I think I have to do a better matching than right now. I was trying to avoid that in the first place because this is the way I attach them here. I have to like cut all of that open and rewire everything. I do have another 4 of these heater on the shelf, so I'm cut them open, measure the resistance and pick the most matching set of 5, and then I'm gonna set them back into the heater block with some thermal paste and rerun the test with the thermal camera again to see if we got a better average. I am really hoping I can get away with not running 4 individual heating zones up there. I mean, I do have at least 4 temperature controllers on the Octopus Pro board, but then I would have to take this out, drill holes, rewire a lot more, and it isn't going to be less complicated at the end. I was hoping I can get away with like a master temperature probe. This was one of the main reasons I had problems with this approach a few years back. There weren't these boards available that plug in by CAN bus and just do everything a hot end needs. I had the same problem with the heaters not matching enough to have a good heat control over all these hot ends. And what I did then was wire my own, which were in the range of plus minus 0.5% of resistance all over these 20s. But as I said, I was hoping I can get away not doing that here on this project, because this was a massive pain in the ass. Let me do that and see again. I measured a total of 8 heaters. These are the resistance values. As you can see, these don't necessarily correlate with the temperature readings. And yeah, that was somehow to be expected. I could see on the thermal camera that these aren't evenly distributed over the whole length. They have hotspots mostly in the front and in the back, so measurements differ depending on where I put the probe. I tried to do it as best as possible, but let's try to assemble our dream team here. The one with the highest value will be kicked out. I think also these two. And maybe we could use the 13.9 symmetrically in lane 1 and 5. And then somehow take 6 and 8 in lane 2 and 4. And then just put this one in the middle. This is also not the perfect measurement, because the temperature probes are only sticking in with like 80% of their body. But I guess measuring the resistance comes closest to their actual heating power. I'm gonna set them in with thermal paste. There is the variable of the hole size taken out of the equation. Let's see what the heat distribution is after I put those in like that. As you can see by all this mess here on the machine, I found a few things that are pros and some that are cons, I guess. So let's start with the cons. I couldn't see any difference in the extrusion after getting like selected heaters in there. Let me extrude some material at 100 cubes. There's the pre-melted material, and as soon as I think I'm gonna have to up the speed a bit. Let's make that 150 cubes. You see, it is pulling to the side. I got some kind of a temperature drift I can visualize with the thermal camera, but also I don't really trust that. It's good for a big picture, but not for comparing a few degrees, I guess. Maybe I need a little bit of help from you guys. I'm a bit stuck here in integration hell. I don't really know what to think of this situation. So when I take the temperature probe and get like 50 points on here, I can see they're pretty much in a range of a few degrees. And I don't think that is causing the main issue. I don't hope there is something blocking in one of those channels and there is whatever interference with the flow in one of these channels and that's causing it to drift to one side. I guess there is not a real probability of a clogged nozzle. So I would like to know in the comments what you think of this situation. I want to get away like taking this apart for now, because it's like one day of work to get it back together, and when I take it apart and I find something that's more like a week. So I don't want to do that at this point and get more data before. And while talking on more data, maybe you saw it before, maybe no, I got a clip where I like extrude some material and then ramp in air. And the interesting fact about that is that I can pretty much dial in my grain size here. This stuff here is pretty interesting because this was at a point where I could barely see the needle moving on that pressure regulator. I don't know, maybe 0.25 to 0.5 of a bar. And what basically was happening here is that I get a very controlled diameter of the extrude. I could basically build up like a sugar cone in 3 dimensions. So it was cool to the touch. I can't really touch hot stuff. I'm kind of a girl when it comes to this. No offense, by the way. But this is like sub 50 degree. And this is really interesting because I thought we would need kind of high airflow, but this isn't the case. It may be just have been too high for the entire time being here. So what I want to do now, let's do a simple print. Controlled amount of cooling air, and don't go too crazy with the extrusion rates right now. Let's go somewhere in the 50 to 80 range or something like that. And let's see if we can get at least a solid print out of here, which I do like in optics. Let's have a look. So I haven't done anything to this print. As you can see, two of those surfaces actually look pretty darn good. I mean, of course, there's retraction, etc., but two of those don't. Without dialing in anything, this is pretty much spot on. So again, I would love to hear your theories on why we have four sides that are all looking different. Well, I would say I'm pretty sure it isn't about cooling. Let me know in the comments what you think this is all about. I had a good night's rest over yesterday's testing, and I don't see any other option than taking the hot end apart to see what's going on. I've gone through the whole list of things that could be in the way. I checked that each of these extruder is pulling the same amount of material. That is correct. I checked the temperatures of those cold ends, and I'm pretty sure there's nothing wrong with the heat breaks. I checked both of these heaters from the lower tip. My only guess is that there is something blocking inside those channels and it is messing with me. The only way to find out is to crack this open. This may lead to some more work, but I have to know what is up, because when I ran the same G-code from the very first tests, it differs now, and as you can see, the stream of filament is exiting at an angle that is a serious sign that the melt inside there isn't homogeneous, and yeah, it's running off to one side because viscosity is different. So let's see if there's something inside. I'll take the opportunity and actually have a look at what's in there mixing. So I'm going back to a 4-color filament setup, and then I'm gonna extrude some material, block it off at the nozzle, and let it cool down in that state, so we have like material inside those channels, and see how it looks while it's working. A wise man once said, "The shortcut is the longest distance between 2 points," and we'll see if it was a good idea to take this apart on the machine. I'm curious to see if I can disassemble and assemble it again without taking everything off here. I've loosened all the screws and I will try to get the front half off of it. Maybe we can just put it on there again. I'm heating it up right now. In hindsight, it would have been a smart idea to have one of these screws actually to push those apart, or have something to like latch in with a screwdriver or some sort of tool. Yeah, I do give you a few seconds to admire what we're looking at. So the missing piece of the violet is over here. At first, in the first second, I thought this was clogged. Yellow and violet seems to be working pretty much as intended. Trouble starts at the right hand side. So here's your answer on, does it mix? No, it does not. It's a pretty laminar thing, except for a few exceptions. So as you can see here, the yellow material is a bit wandering into the violet side up here. So the thing that buggers me the most is the blue has like this pitting in it on both sides. So the question here is, are we dealing with moisture? Or are we dealing with air pockets that are trapped inside of here? You can see it in this corner here at my thumb. There is another void. So the way I parked this hot end was I was extruding material constantly. Right when it stopped moving the extruders, I put this feeler gauge on the bottom of the nozzle, and there was no further material coming out of there. So I basically trapped everything inside of here. And we should have a pretty solid representation of what has been going on during the extrusion process. You might be tempted to say that this and this is a working extrusion, working as intended. And well, yeah, this is moist filament, and this is just some other filament as a lower melting point or something. But I think that is only part of the explanation here, because I had the same issues when I was running just violet on all 4 channels, and this is basically from the same spool. So just to get our events straight. When we started this process and put 4 materials in there, there was material coming out pretty straight. I mean, the first benchy hasn't been looking too bad. There were no such signs. When I switched the filaments, I switched the most outer ones to get a different color representation in the extrude. Then it started that the melt was flowing to the left when it exits the nozzle. This kept going while I was putting in 4 times the violet filament. And then when I switched back to this setup to prepare for a good representation of what has been going on, I did some extrusion, and I will put the video right here where it was severely running off to the right hand side, and it would already start to spiral out of there. Please let me know in the comments what you can read out of these T-grounds and what I should be doing. This for a complete comparison. I think I changed my plans. I discovered something when I was cleaning the hot end. So have a look at here. What do you guys see? So these were the 2 channels to the left, violet and yellow. This was blue and red. We made the observation that these 2 channels are actually working pretty damn fine, and all those problems come from here. So what I see here is that we got some serious oxidation going on in these 2 channels. As you can see, these mating surfaces have just seen like a few hours of oxygen, and they haven't really made any weathering process, just like these channels. But why the hell did these 2 channels oxidize, and more precisely, why did they do that in different amounts? So I think the question to why is our filament running off is right before our eyes. The question is, why does that happen? So, but I think I know what I have to do, because another fact, I could just pull these materials out of here with a fingernail. This one I had to heat and scrape with a toothpick, etc. This was sticky as fuck. So I guess we have kind of laminar flow here, even though the surface is scarred up. But we have very turbulent flow here, and that may be causing a very uneven heating of the filament or something, and that's why it is causing so much problems. The other question is, how good is my measurement on the temperatures? I kind of trust my measuring equipment in terms of, let's say, plus minus 5 degrees. And I don't think a difference of that little would make this oxidize and this not. But if there's any company that would like to send me some hardware to actually properly control this temperature in here, write me an email. I think what we'll do is I'm gonna reset all of those surfaces and then I'm gonna nickel plate the insides to prevent that from happening. And yeah, let's see if that makes a difference on the long run. Speaking of long run, this is going to be, I guess, the longest video of them all. Please leave a comment down in the comment section whether you like it or not. I'm gonna include everything because I want to give all the information away. And if you guys want to build something, some contraption like that, there are all the information on the table and you don't have to hit your head to the wall like I do all the time. Give me an honest feedback on that situation. And usually I was planning to end this video kind of here, because there will be a lot of things involved to get this up and going again and end with like a positive note. But I'm willing to go the extra mile. So let me know if you appreciate it or not. We've been at this point before. As you can see, I went ahead and did the bead blasting again to get all those oxide off. Basically reset it. Then I gave it the fine lap again, so mating surfaces are in pristine condition. And now I'm gonna nickel plate it. While we're at it, I was already 5 minutes into polishing these channels again. And then I thought, well, this is all about making it as even as possible, so the distribution of the four filaments completely cancel out. And then I decided that the bead blast finish will be the best for making the surface as even as possible. So I left it as is. I don't think we have any performance issues whatsoever. This thing is, in terms of melting capacity, way beyond what we need. But what I care the most is that the extrusion quality and control is up there. Nickel plating will be done in 2 steps. First, I'm going to use some electro cleaning agent to get rid of those freshly formed oxidation layer on here. And then we're gonna do some nickel plating with nickel electrolyte, and we're gonna use some graphite electrodes to do this. I think I'm gonna do a time lapse of this and then we'll see with the finished result, I hope. A very quick FAQ. Is this the best nickel plating job in the world? Well, probably no. But will it deliver? Is this our problem here? Probably yes. I went ahead and put these 4 thermistor bores in here so we can monitor what's going on. And they are sitting exactly behind those channels, 20 millimeter in the path. So basically just between those heater cartridges. Can monitor these 4 points and afterwards we can make whole PID loops out of them. But for now I just want to control what the temperature drift says in here and get some more valuable data, especially when extruding. And also for this test, gonna put in a fresh nozzle just to be sure that there isn't a partial clog in the existing one. This will be 0.4 millimeters and I just went ahead and ran a countersink to give this a fighting chance of get the filament in here. So I guess we're at a point where like 100 cubes is fully enough in printing moves. We can do that with this nozzle. Also, this might help with the die swelling issue because we're keeping those polymers in a tighter space for a longer time. So what has been a few minutes to you has been like 6 to 8 hours for me, but I got everything back on the machine. And I think it turned out pretty dope. Everything is back on. I got another thermistor plugged in. I don't have enough thermistor inputs on here to have all 4 of them, so I decided to have just one of them and plug it around. As you can see, this is my lane check here, and it's already showing some discrepancy, but that's kind of normal because it sits way higher and this is way closer to the cold ends. They are pulling heat away. This is all set up again, and all these 4 filaments came from the same spool, and they have been in the drying chamber for the last 12 hours at 70 degrees, so any moisture should be out of here. And I've made sure this is completely drained, or no material has been inside of here. All the filament rolls are pretty much to the exact point here at the cold end side, so if there's any air or whatsoever, I'm gonna push it in with the extruder so no air could get trapped or anything. I'm taking you with on that journey, heat it to working temperature, and then we start to extrude some material, and we'll see if all of that work does pay off at the end. Okay, 215 degrees extrusion test, starting at something mediocre like 40 cubes. All right, 60 cubes. $100 cubes. All right. That seems to be coming out straight as an arrow. I will keep an eye on how that develops in the future and what I've done before when this... I've also checked the lanes. I've put the thermistor in each of these holes and let it settle in. This is all pretty much consistent, and since we're doing that measurement with just the single thermistor, there is no error in between these measurements. So there is no uneven heating in here. I can give you a better example when I have all these wired in, but I have to cut a few corners to do this. Maybe add another board or free up another analog input. We'll see about that, and maybe we could later on make different heating zones and have each thermistor connected to just one of those heating cartridges, and yeah, make this as accurate as possible. But that's something for the future. I'm now gonna do, if this works, this will be pretty much the end of this video. I sliced up a benchy at mediocre speed, let's say 10 minutes, at the 0.4mm nozzle. I'm just gonna have you guys on board, set the camera up, and just let it basically play for the entire time if it finishes. So let's have a look. Keep in mind, this is print number 13. This machine has less than 1.5 hours of real printing time on its counter. There are so many parameters to be touched, and trust me, we're gonna touch all of them. So yeah, there you have it. This hasn't been an episode, this has been a journey, and you were part of it without any corners cut. Again, leave a comment in the comment section. I absolutely love this community that has built up here. I can see in the analytics that there's a growing community that is watching these videos but aren't subscribed. So maybe hit the like and the bell button, you know the deal. This really helps to spread the word about this project here. And yeah, get all these information out to the people in this awesome community. This is by no means the end. I now know that this system is working. Now we can cut down times. So watch out for progress in this December. Bye. You just saw some footage of me putting pudding